Hey gang, so this is page 10. This is after your check for understanding over example 16 that you should have already done. So we've been doing trapezoids and finding the area under the curve using a trapezoid. But now I'm going to give you an actual rule called the trapezoidal rule. It says if you take the integral from a to b of a function f of x dx, here's what dx is going to be. It's going to be our delta x. This is the rule. Now, this is it broken down. And you know what? I just realized that I left off a bracket at the end right here. So if you want to add that bracket in, so you know, it's delta x over 2 times all of this. Now, this looks a little confusing, but it's really not bad. It's doing everything that we've been doing, which is adding up all the different trapezoids. But what if you had hundreds of trapezoids? You don't want to sit and find the area, just like on this check for understanding you did. You don't want to find the area of this one, and then the area of this one, and then the area of this one, and then the area of this one, and add it all together. That gets really old. And what if you had 100 of these? You really don't want to find each one. So this is a general rule that will work. In your formula booklet for your exam, this is what it gives you. The integral from a to b of y dx is approximately, because this is not going to be accurate, it's just going to be an approximate. The area under the curve from a to b of a function is 1/2 times h, and then you're going to add, this is how it works, you add the very first one. So if I'm going to use this one as an example. You would add this trapezoid and this trapezoid together, and then you add up all the other ones, first one and the last one, and then add up all the other ones and multiply, double them, double the other ones after you add them together. Now, what is h? H is nothing more than, h is the distance from B to A. What are you going to, like from 1 to 5, so it would be 4, divided by how many trapezoids you're dividing that into. B minus A over N. It's a formula. You're always going to have it. It is not difficult to work with. It is just a little bit tedious. There are questions on your IB exam regarding the trapezoidal rule. IB really likes the trapezoidal rule. All right, so here we go. So we're going to approximate because, again, we're not doing it exactly. It's just an approximation. The integral from 1 to 5 of 1 plus x squared dx. The number of trapezoids we're doing are 4. I'll give you a second to look at it. First thing we want to do, we're going to use this formula. So let's figure out what h is, okay? So let's do h. Remember, h equals b minus a divided by n. So let's come down here, let's label what a is. If you remember doing quadratic formula, and you had a, b, and c, and a lot of times you could just look and go, oh, there's a, there's b, there's c. I always teach my students, try and write it out before you start. So we're going to do that same thing. A is on bottom, so that's 1. B is on top, that's 5. N is the number of trapezoids, that's 4. This will help us as we go and try and solve the rest of this problem. All right, so h equals 5 minus 1 divided by 4, which is 4 over 4, so it's 1. So I'm going to come back over here, and I'm going to now say that h equals 1. All my variables are labeled, and I should be able to do the rest. All right, so here we go. So we need to find, remember I said we have to do the first and the last trapezoid. And so, you know what, let's do this. Let me come over here. Let me move this little thing. I don't know if y'all can see the little reindeer that I see on my screen. All right, so 1 plus x squared it's going to look something like coming up 1 and then x squared. So it's going to look something like that. So here's what I'm going to do. I'm just going to draw a line down. I'm dividing this into 4 trapezoids, right? So I'm going to say, and I'm going from, what was it, 1? 1 to 5. So here's 1, 2, 3, 4, 5. Oh, I did pretty good on that. 1 to 5. So 1 to 5. And so when we divide it up into 4, when you think about it, it's going to be 1, 2, let's see, I'm going to make this one solid, and I'm going to color it in. So this is where I'm working. I'm finding this area right here. Okay, 1, 2, 3, 4. When you think about it, this H is like the distance here between each of those. Okay, so we need to find f of 1, f of 2, f of 3, and f of 4. Now, why am I not actually finding what we did before, where we find this point, this point, this point, this point, and this point, and then we calculated the A and the B, and then we did the height? We're not going to do that now. Now we have a shortcut. Okay, we're going to use this formula. So f of 1. So if I do 1 plus 1 squared, that's 2. F of 2 is 1 plus 2 squared. Well, that's 5. 1 plus 3 squared is 10. And 1 plus 4 squared is 17. And then, oh, I'm going to need that 5 over there too, because we're going all the way over there. So 1 plus 5 squared equals 26. Okay, I get all of them. I got the first one, and then f of 2, 3, 4, and f of 5. So you need every single line is going to need to be represented there. Then what it says here, what my rule says, is that I take 1/2. I'm going to do this over here in red. I'm going to take 1/2 times h, which in this case is 1. Now, I'm just going to go ahead and put it in, but, I mean, you know, I'm not going to really need it. I take the first and the last, so 2 plus 26, right, plus 2 times, I'm going to add up all the other ones, 5 plus 10 plus 17, and that's going to get me my answer. All right, so 1/2 times 2 plus 26 is 28, plus, let's see, 15 and 17, and then we need to multiply that by 2, so 64. I'm going to double check that. Pretty sure that's right. 5 plus 10 plus 17 times 2, 64. I had it right. I'm going to put parentheses 64. So 28 plus 64, cut in half. I'm going to do my approximately. 12, 90, half 9, 46. So I should probably write it as the integral from 1 to 5 of 1 plus x squared dx is approximately 46. That means the area under that curve right there is approximately 46. All right, that's the trapezoidal rule. It is in your formula book for you. Okay. And let me pull this down. Okay, so here's our next one. Example 18. Okay, so the diagram below shows part of the graph of y equals, oh, I didn't get that over there, but that's okay. E to the negative x squared, and the region bound by the graph and the x-axis, and the lines x equals negative 0.5 and x equals 1.5. Okay, let's actually write that mathematically, what they just said. They're talking about the area under the curve, so we're talking about the sum. And we went from negative 0.5 up to 1.5. The function that we're doing is e to the negative x squared. And then we want to be sure we do delta x, the change in x. That's what they're wanting to know. They're wanting to know what's the area under that curve. Okay, so here's what it says. It says find the area of the shaded region using a graphic display calculator. Round your answer to 5 decimal places. Okay. Then it says find 4 numbers, not including the endpoints, that divide the interval negative 0.5 to 1.5 evenly. Use the trapezoids corresponding to this division to approximate the area of the region. Use the same accuracy as the first part of the question. What is the percentage of error? Okay, since we just did the trapezoidal rule in the last one, let's do the trapezoidal rule first, and then I'm going to show you the wonderful things that your calculator can do. Okay, I feel like that's blurry. Okay, it's just my contacts, you never know. Okay, so if we're going to use the trapezoidal rule, we want to first start off, and maybe you want to write that over here, I don't know. We need to find H, we need to do A, we need to do B, and we need to do N. I'm going to give you just a minute to kind of see if you can label everything. I'm going to do B is 1.5, A is negative 0.5, and remember for H, I'm going to take B minus C, nope, minus A, which is negative 0.5, and divide it by the number of trapezoids that we're going to, the number of things we're going to divide it into. And I think it said 5. Didn't it say 5? Use the trapezoids corresponding to find 4 numbers. Okay, so we're going to find 4 numbers, but how many trapezoids is that going to create? If we have 4 numbers, it's going to actually create 5 trapezoids. All right, and so we're going to have, I'm going to put 5 down here. So when you do that, I actually got 0.4. So that means, not including the endpoints, we're going to put 4 lines in here, right? So I'm just going to put dots up here. Line, 2, 3, 4. If you're stumped on where'd you get those 5 trapezoids? Here to here is going to be 1, 2, 3, 4, and that's going to be my 5th one. So if 0.4 is going to be the distance, I need to go from here over 0.4, over 0.4, over 0.4, over 0.4. So what I'm going to do is I'm going to take my calculator. I'm going to start at, clear this out, negative 0.5, and I'm going to add 0.4 to it, and I end up at negative 0.1. So right here at negative 0.1. Then I'm going to add 0.4 to that, and I'm at 0.3. This is 0.5 right here, so I'm like right here at 0.3. I'm going to add 0.4. I'm at 0.7 plus 0.4 again, and now I'm at 1.1, and then plus 0.4. I should be at the end, and I'm here. Okay, so I'm going to circle these. I'm going to need to do f of negative 0.5, f of negative 0.1, f of 0.3, 0.7, 1.1, and 1.5. I need to do f of each one of those in order to figure out what this is going to equal. All right. So here we go. So I gotta get my rule. Where's my, okay, there it is. So, okay, so it's 1/2. I don't have it quite memorized yet. Times h. H is 0.4. Times, we're gonna add the first one and the last one together. Okay, so I wonder if we could write it in there. Are y'all good if I do that? Or do you want to, I'm trying to think. I think I'm just gonna put it here. We're gonna do f of negative, we're going to do that first one, 0.5. I need to find that right there. And then I need to add it to the last one, which is f of 1.5. F of 1.5. Okay, I'm doing the first one, so I'm going to put parentheses around these, plus parentheses, 2 times, and now I need to do all the other ones added together. So f of negative 0.1 plus f of 0.3 plus f of 0.7 plus f of 1.1, and then we're going to close our bracket. Okay, So when you look at that, it's like, oh man, that's super messy. Okay, so let's go into our calculator. Let's go to y equals. Let's put that in. E, second division gives you the E. House top, negative x and square it. So there's my, I'm going to make this just a little bit brighter. Okay, there's my equation. Now, you could go here, and it's yucky numbers. You know, we could do second table set, and we could put in like this 1.1. We could say 1.1 second table set, and there it is right there. Except it's a whole mess of numbers, and it's like, how is this going to work? So I've learned something on your calculator that is really, really helpful. So we're going to quit this. We're going to clear this out. So what we're going to do is we are going to say I'm going to do 1/2. 1/2 times 0.4. Parentheses. Okay, that's my numbers in the front. I'm going to do this so we can see all of this. Now, first off, if you didn't put this into your calculator, you have to do this part first. You got to put that in here. Over here, I'm going to, and this is where I get a little bit like I need to make sure I'm following. Parenthesis. I'm going to do alpha y equals y vars. There's my y1. I want to evaluate that at negative 0.5. Okay, my calculator is going to do that. Plus alpha y equals y vars, parentheses 1.5. Okay, it's super hard to read because it's like kind of crazy. But just know, make sure you have the first two out here. This is your first bracket, and then this is your parentheses. So we've added those together, plus parenthesis 2. And now we're going to do the other side. Alpha y equals, and then we're going to do y of negative 0.1. Oh, hello. Why did we do that? Oh, because I forgot to do the y vars. Alpha y equals y vars. Enter. Parentheses. Negative 0.1. Okay. Y of that plus alpha y equals, oops, I graphed it. Get it all the way to the end. Plus alpha y equals y vars, parentheses 0.3, plus alpha y equals y vars, parentheses 1.1. Oh, I forgot the 0.7. It doesn't matter what order you put it in, you're going to do the same thing, plus alpha y equals y vars, and I need to put in the 0.7. Okay, so I've got 0.7, I've got 1.1, I've got 0.3. This parenthesis here, I need to add one more. Now, if it tells me I have an error, then I'm just going to go add another one, and if it gives me another error, then I'll remove one. Okay, so there it is. I'm going to double check and make sure that that's what I got when I did it the first time, and it's not. Okay, 0.4 1/2. Negative. Did I put the 2 in there? Okay, let me copy it down. It's such a messy equation. I don't know if it might be easier to do it the other way. Okay, so here we go. So I did that one. Okay, so my first two are oh, I know where I forgot, right here. I need to second insert a parenthesis. Y1 of this plus Y1 of point, that right there, I need to insert a 1.5. Okay. Sometimes it's just going back and looking at what you did, plus right here, I forgot, what did I forget right there? I forgot my 2. So I'm going to come right here. I'm going to second insert a 2. So 2 times that plus that. Okay, I think that's right. There we go. Now I'm good. So sometimes you just have to go back and look at your equation and see what you can find. Okay, so here we go. I'm going to set that there. So I'm going to say this is approximately, and I'm going to write that down, 1.302761879. Okay, so that's the approximate. So what it wanted me to do was it wanted me to find the exact area under the curve. Okay, this is where you're going to be like, really? Why are we do it that other way? Okay, so I did y equals, right? I'm going to come down here, and I actually have to remember it. Calculate. Look at that. See that integral right there? That's the area under the curve. What's the lower limit? Well, the lower limit on mine was, let me get over there, negative 0.5. So negative 0.5. Hit enter. What's the upper limit? The upper limit was 1.5. Okay, don't hate me for this, y'all. There's the area right there. See that? It shades it. I'm going to zoom in on that because it's super cool how it looks. Okay, so I'm going to do that again. Second, calculate number 7 for the area under the curve. What's the lower limit? Negative 0.05. Oops. Nope, that's not right. Negative 0.5. There we go. What's the upper limit? 1.5. It shades it, and then it tells you that the actual, I'll put it over here, that the actual is 1.31746. 1.31746. 31746. I'm just going to put that on there. 94. That's the actual. Oh, you didn't have to do all that. Okay. Yes, they are going to ask you to do the trapezoidal rule, though, so be sure you know that formula and you know how to use it. Now, the last part of this is what's the percentage of error? They ask us that all the time in this class, and so we seem to always be doing the percent of error. Percent error. So remember, that's where you have the big E. It equals. We're going to take the approximate 1.302761879. We're going to subtract off the actual 1.3174694. We're going to divide by the actual 1.3174694. We're going to take the absolute value of that, multiply it by 100, and let's see what we get. So here's the really nice part about this. You've already got these numbers in your calculator. So I'm going to take, I'm going to do alpha y equals. And then I'm going to go up here and grab that number, and I'm going to say minus 1.3174694. And then right there, I want to put that number again, 1.3174694. Oh, and remember, I'm taking the absolute value of it times 100. So it's not a negative, it's a positive. It's the percent error is it's really approximate, 1.12%. So it's not too bad. I mean, we were pretty close. A 1% error, that's not too bad. All right. So hopefully that made sense. I hope. And now we're to this. So we are going to do the same thing we've been doing with the trapezoidal rule. I need to be sure you know how to do these, okay? Okay, there we go. My computer went to sleep. Okay, so here we go. So what we're going to do on this is we're going to determine h. So what we're doing is the integral from -2 to 8 of this function. We're going to make two trapezoids. What is h? So remember, h is b minus a over the number of trapezoids. So that would be b minus a minus 2 over the number of trapezoids, which is going to make this one 5. Okay, so that one's going to be 5. The f of x values. So we are going to have to find, we're going to have to do a whole bunch. Okay, so I think what it's going to do on this, looking at how my notes did it, I didn't do all of them. And I didn't really leave us any room to really work on this. Let me get a piece of paper. You made just a little piece of scratch paper here to kind of help you a little bit. Okay, so here's what I'm going to do. I'm going to go here, because all of these are going to be the same. Let's do y equals, and let's do the natural, these are going to build on each other, so it shouldn't be too terribly hard to get through. X plus 3 plus the natural log, that's got a parenthesis on the outside. Let me put that. Parenthesis, natural log 9 minus x squared, parenthesis. Oh, that squared is not there, is it? Parenthesis, and then it's squared. Basically, we're squaring that whole thing, right? It wouldn't matter which way you did it. All right, so let's graph it. Let's see what it looks like. I can't see it, so I'm going to zoom 6. There he is. Okay, so it looks something like that. So if I were to graph this, let me see if I can move this up a little bit. It looks kind of like that. And so we're going from -2, so we'll call this -2 right here. And we're going out to 8, which is basically right before it does that little hook. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 is right here before that hook, before it hooks up. So we're finding the area under the curve of this right here. Okay, the number of trapezoids. We just want 2. So that means 5 is where we're going 5 units from here. So we can either go back 5, 1, 2, 3, 4, 5, and we would be at 3 right here. So these are my trapezoid 1, trapezoid 2. So my f of x values, I would need to find f of -2, f of 3, and f of 8. Now, you've already got that in here, second table. Let me go back here because I changed it earlier. -2 is that. I'm just going to do this. 5.7499, f of 3. I'm going to keep these numbers right here because I think it's going to be easier just to have these written out than it is to try and put them in my calculator and do it the other way. You could. 3979. What's the approximate area? Okay, so remember our formula. Second, quit. Clear this out. We're going to take the first one and the last one. We're going to add them together. So again, you can do one of two things. If you don't want to write it out, you can do alpha y equals y bars, and you could say f of -2 plus alpha y equals y bars, f of 8, parenthesis, parenthesis, plus 2 times, and then f of 3, alpha y equals y bars, parenthesis, -3. I don't think I had enough errors on a thing that parentheses on there. Okay. Parenthesis. I think I need another parenthesis at the very beginning. So second, insert another parenthesis. Nope. I can quit. Okay. -2 to 8 at -3. Oh, not -3. Just 3. Sorry. Delete. Don't hit clear because it'll clear everything out. There we go. Okay. So there's that, but it's not done because remember, you have to multiply it by 1/2 times h. So I'm going to say times 0.5 times 5. I thought I had my answers in here somewhere, but I don't. But I know that's right because I remember these numbers. Okay, so the approximate area is 45. I'm going to do, I think 4 decimals, 380, and I'm going to say 3. All right, so that's the first one. So now I've already got this in, but now I'm doing 5 trapezoids. So you might already be going, well, this should be way more accurate. So I need to do a minus b, so 8 minus a minus 2, but this time the number of trapezoids is 5. So that's 10 divided by 5, so my units now are 2. So this is where I should have left you guys more room. So let's take my picture, and we're going from -2 to 8, but now we need to divide up every 2 units. So that means we would be at 0, 2, 4, 6, and then 8. Let's double check. There's 1, 2, 3, 4, 5. On the IB exam, I hope you get a question like this because I don't think this is difficult to understand. It's tedious, but it's not hard to understand. Divide it up into every 2 units. We're going to put a trapezoid. Bam, we got 5. It says we need 5. Done. So what do we need? We need f of -2, f of 0. So we're going to add f of 0. Since we don't have it listed here, we need f of 2. So let's add f of 2. We need f of 4. We need f of 6. And then we already have f of 8. Okay, so this time I'm going to do this. I'm going to do alpha y equals, and we're going to go to 0, which is 5.9264. F of 2 is 5.396. F of 4 is 4.5362. F of 6, 3.4042. This time, let's do it the other way. Let's use our numbers, okay? We did it the other way last time. I'm just going to use my numbers this time. So I need to take the first and the last. So I need to take parenthesis 5.7499 plus f of 8, 2.3979. I need to add those together. Plus 2 times, and then I need to add all these down here. Don't do the 3. You're just doing these down here. So 5.9264 plus 5.396 plus 4.5362 plus 3.4042 parenthesis. Okay. Oh, I got to multiply it. Times h times the number of, what was it? H times 1/2 times 0.5 times h, which in this case was 2. Okay, so we got 46. Oh, 1/2 times 1/2 is 1, isn't it? Oh, okay, Mrs. Dean. Oh my gosh. Okay, so there we go. All right. Rocking and rolling. Now, some of you are like, oh, come on, do we really got to do this one? I'm going to encourage you to do that one, okay? I really think if you do that one, it'll really help you. I'm going to go ahead and keep doing it. You can fast forward the video if you want. All right, so here we go. So I'm going to say, let's see, it's going to be 8 minus a minus 2 over, this time 10. 10 over 10 is 1. So that means we are doing every single one. So f of -2, f of -1. We already have 0. We need f of 1. We already have 2. We need f of 3, f of 4. So we need to add f of 5, f of 6, f of 7. And that should be all of them. All right. Here we go. Alpha y equal, no, sorry, table. Okay, so we need f of -1, 5.995, f of 1, 5.7104, 4.0013. I hope you're still with me. All right, second quit. I think that was actually a little faster, so I'm just going to, since I already have my numbers. All right, 5.7499. The first one plus the last one, which is f of 8, 2.3979. Plus 2 times all the other ones. So we're going to start with, we're at -2, so let's do -1 next. 5.995 plus, after -1 would come 0, 5.9264 plus 1, which was 5.7104 plus 2, 5.396 plus 3, which is up here, 5.0022 plus 4, 4.5362 plus 5, 4.0013 plus 6, 3.4042 plus 7, 2.783 parenthesis. Oh, I hope I don't mess up anywhere. Okay. Times 0.5 times 1. So it is 46.8286. Okay, here we go. Now we're going to actually do the exact. We've got all these estimates, and you can see when we only had 2 trapezoids. But look, these are a little bit closer. So here we go. We're going to go to y equals. We're going to second calculate the area under the curve, number 7. Our left boundary is -2. Our right boundary is 8. There it is. The exact is 46.872071. This is the exact. The others were approximates. So you get the idea. The trapezoidal rule, the more trapezoids you have, the more accurate you are going to be. And I think that concludes the video on trapezoidal rule. I hope it was easy for you guys. Cognity asks a lot of questions like this. So anyway, and so does the IB exam.